Okay, guys, we welcome to the Thursday lecture for the XR ARIVE lecture series. Sorry about that. So Maxime from Monash University is giving a talk about their toolkit, about their immersive analytics toolkit. So we have a couple of students here in the room and perhaps others outside as well. I will just hand over to you. Tim already gave a very brief introduction to your group. And so I hand over to you to give your talk. Thank you very much, Maxime, for doing that.
Thank you. Thanks, Holger, for the introduction. So hi, everyone. So yeah, my name is Maxime Cordeil. I'm a lecturer with the Monash Immersive Analytics group. And today I'll introduce the work I've been doing with some of my colleagues here in Australia and at Monash on building a prototype toolkit for immersive analytics. So just a quick overview. This is basically just a visualization toolkit we built in Unity to help research community, but also other people involved in immersive analytics to create like fast prototypes and advanced prototypes, almost like things that really work well with data visualizations. So we've been throwing a lot of engineering and design in that prototype toolkit. And it's basically there, yeah, as some sort of like as an accelerator to build immersive data visualizations. So as I know, Tim has introduced a little bit the field of immersive analytics in the previous lecture. And by the way, I think my slide is a bit outdated, but I'm working with these people. So Tim is leading the lab locally. So we actually even have a few more PhD students working on this topic. And I've actually done a lot of work with also people from UniSA, and there is obviously Bruce and Andrew, but could mention Mark Billinger also on that slide, and many more people now as the field of immersive analytics is growing. So before I will introduce the work on that data visualization or immersive InfoVis toolkit, I would just like provide a quick overview of what's happening a bit. I just want to focus the lens on abstract data visualization in immersive analytics that will lead to just the demo of the toolkit. So why are we interested as data visualization researchers? Because something that is quite unique in our immersive analytics group is we are like really into the InfoVis community, the IEEE community. And we are basically interested in a lot of different ways to explore multidimensional, multivariate data. And for that, VR and 3D interactions and AR offer like unique opportunities. And so we've started like exploring those design opportunities and for the past 5 years now. So the design space is very vast, very, very big. And we started finding some bricks that are very interesting for the visualization community. And I would just focus on a few of them today. The first is the interesting thing with immersive analytics for us doing data visualization with 3D UI in immersive environments is to leverage embodied interaction. And I will talk a little bit about that and why it's interesting in immersive visualization. It's also about leveraging the space. So in visualization, people work with a lot of views, and so there is unique opportunities in these environments to basically arrange external cognitions and representations of data around the user. And there are also unique opportunities for design of abstract visualization in 3D, and I will just talk about that a bit later as well. So one of the strong motivation of the building that toolkit, it's a bit of a backward problem. We started building interactions for building data visualization in VR. And so for that, we focused on multidimensional data. And just a very quick overview of multidimensional data for the people who don't necessarily have the background. Multidimensional data is pretty much everywhere. It's ubiquitous, and it's basically data that can be described by one or more dimensions or attributes. So if we take something as simple as wine, for example, we can describe wine by a lot of dimensions like volatile acidity, the type, the amount of alcohol, and so forth and so forth. And so what we do when we do visualization, we try to make sense of potential large databases, data sets of multidimensional data. And so conventionally, what we would do, we would build scatter plots, for example, to view the distribution of data, of continuous data. For example, we would build like parallel coordinates or this type of visualizations that are used in data science and visualization to make sense of the data. And so one of the first little tool we started building was called Maxime, where we basically put a multidimensional data set into the immersive space. And we build on that concept of embodied interaction with the data axis. So here the data axes are basically the dimension of the wine data set I was talking about. And they are just there available with a sort of like pseudo shelf metaphor that the user can grab directly and assemble them into a meaningful way. And so this basically giving us some sort of like modeless interaction to build actually InfoVis representations around in the space around the user. And so as you can see, there are some meaningful interactions that the user is performing, and the user is me there. But I'll talk about it a bit later on. And so we've basically been building on this concept of embodied affordances. So as I just briefly say, I won't do a talk on Maxime, but this is like motivating the work on the toolkit. Embodiment what was interesting in that work, because we were sort of thinking of a paradigm, an interaction paradigm to author visualization, because when we explore multidimensional data sets, what we do is we author and we build visualizations. So we created this perceived embodied affordances based on the concept of embodiment and affordances. Just a quick note on the design. Since these axes are perceived as being embodied in the space, let me see if I can play the animation. But anyway, I'll show the real data set. We started building a modeless environment in which the user intuitively could arrange the visualizations as if they can manipulate those axes as sticks. And if they assemble them, for example, orthogonally, in an orthogonal way, they should see a 2D scatter plot, or if they add a third dimension, they should see a 3D scatter plot. Same thing if they just hold two pieces of dimension next to each other, that should show a parallel coordinate. So what we built basically is we built a spatial grammar to interact with multidimensional data with these 3D interactions in VR. That basically, in a modeless way, allows users to create all sorts of visualization. So very quickly, there are basically a bunch of rules that are looking at the position and the orientation of the axes in space. So if the axes are just standing there, oops, and this is cropped, but never mind, I'll link the paper. If the axes are standing there, they just show the distribution on the dimension. If they are being brought next to each other, they'll show a 2D scatter plot. And so there are rules of compositions. So if we stack axes on already existing visualization, we can create what is called a scatter plot matrix and basically extend the visualization. This also works in 3D, and so forth and so forth. And so this is showing the rule of 3D. And so you could, from this rule, you can also build 3D scatter plot matrices, for example. So the grammar, the spatial grammar we built helped us recreating at least the atomic visualization, the thing that exists already, the visualization types that exist already in database. But the interesting thing is that we managed to find emerging visualizations by leveraging that space. For example, connecting visualizations together in that way, or creating new visualization paradigms for example, 3D circular one-to-many PCPs. So, or trees of connected scatterplots, for example, and so forth and so forth. So that work was done in 2017, and I'll link the GitHub there. But 2 years after, what we did is a few people started downloading our software and got interested in using them in a real workplace. So we did this study with the University of Maryland, and they collaborate with the Department of Statistics from the state statistics, and we had the opportunity to work with almost 40 data scientists who use that software in the wild. And what we did is we did a study that we published at IEEE last year to understand how they leverage the space around them to explore data. So this was some interesting research where we mainly found that people tend to really use the space around them. Users really tend to use the space around them to more to present data rather than explore the data. They tend to work more in front of themselves. But I'll link the paper as well if you want more details. And as I said, it's on GitHub. You can download it if you want to play with it. It's working with, it's no screenshot, but it's working with Unity 2019. And with, if you have an AR or VR headset, you can even do IMAXs in AR, it works well too. And this is another work of abstract visualization, and I'll go very briefly onto it to explain the problem that I've done with the French Civil Aviation School, where I studied before, and Microsoft Research, and where we started exploring how VR can help building 3D queries to select, maybe I'll show a bit of a longer video. Where the user basically visualize a large amount of trajectories and selects the 3D trajectories. So we built that tool that is called FiberClay. It was an interesting experience because then we worked with people from the domain of aviation, and we asked them to perform selections of aircraft trajectories in very dense data sets. And the thing is, we also worked with neuroscientists. Let me skip forward, it should work. Because FiberClay can also visualize connected data. So we worked with people who are experts in strokes, and they were visualizing DTI brain fibers with like Van der Ling's algorithm and so forth and so forth. So this was just another piece of immersive analytics work. So bottom line is all those projects were really fun, but when we started building all that, there was no visualization library readily available to do like InfoVis or visual analytics in VR and AR. So we could build from scratch some data visualization, but the problem is visualization requires, first of all, they need to support real data sets, which means that they're potentially large data sets and with complex data representations. Also, InfoVis and visual analytics requires like standard interactions like filtering, brushing, selections, and so forth. To really query the data visually. It's not only about displaying a bunch of points, it's about interacting with them, drilling down and getting the information about the data. I'm just saying some chat action, but maybe I'll look at it later on. And so, I was originally from a visualization background. And so when I started opening Unity and all this type of stuff back in 2015, well, it was like the desert in terms of visualization. So it was exciting because there was an opportunity to build something. So basically there was a gap between the huge field of InfoVis it's been exploding for the past like 10 or 15 years. And now there are like standard tools that are absolutely amazing that lets you create data visualization, very compelling data visualization very quickly, such as, for example, D3. But there was a gap with VR, basically. So our little modest ambition was to bridge that gap between VR, AR, basically immersive environments, and allowing people to build data visualization that potentially can show like complex representation of the data. So with IATK, which is the toolkit I'm gonna show now. Yeah, we focused on that. We should at least be able to support like, visualizing simple visualization, but like a few 100,000 or million data points. We should create standard visualization from the visualization community, such as like connected graph, but also being able to visualize, for example, trajectories, because then very often they are multidimensional and they also link to abstract visualization. So, so that's the little introduction story of the toolkit. So we decided, so with yeah, Bruce, Thomas, and Andrew Cunningham, and a few other people then involved to design this toolkit. And so I'll briefly talk about the design. So the first thing we focused on was expressiveness, which is basically we should allow users to create a variety of visualizations, not simply scatter plots and bar charts, but also like advanced visualizations, such as linked visualizations, for example, which allows to connect the data points between visualizations, the same data points across the same dimensions, for example. Visualize trail, trend lines that I was talking about, scatterplot matrices, parallel coordinates plots, and so forth and so forth. And to do this, what we did is we started building a very simple grammar of graphics. So this is based on the principle of Wilkinson et al. So the purpose is to create a framework that systematically creates visualization, data visualization according to some view frames, predefined view frames, visual encodings, and visual linkings. So the second aim or requirement for our toolkit was to support simple authoring. And simple authoring means like when we are involved in HR research, we need to cater for different type of people, different type of programmers, people with have different type of skills. And in DataVis, there are people creating amazing stuff, but they can't code. So we need to support some simple authoring. So we did this. So now I'm just going to switch on. I'm just going to switch on Unity. I don't see my screen, so I hope can you see the Unity editor? Yep, thank you. What I'll do just to demonstrate simple authoring. So this is the Unity editor for the one who are familiar with it. And we embedded the toolkit. If you right-click in the hierarchy, you can create an IATK data source. And I'll just demo the simple authoring in a few clicks and the visualization. And so I can just grab, for example, a data set. I'll just grab, for example, the Dow Jones Index data set. I'll just drag and drop it. So I've created a data source. Now my data is in, the data set is loaded in memory in Unity. And I can just link my data source to the visualization like this. Just drag and drop, simple paradigms, just leveraging the UI. And here I can say, for example, okay, I want to build a scatter plot. And for example, let's build a scatter plot with the bind, and we can just bind the dimensions. So here we just created a view frame for a simple scatter plot. And as I was talking about just before, we support a simple grammar of graphics. And I'll just show a few different examples, but I'll start simple with scatter plot. And I can just create a point geometry. And so in 4 clicks, I created an immersive visualization. So if I click play now, I mean, the problem is that as I'm doing the lecture live, it's a bit tricky to have everything connected. But this is in Unity, so if you have a plugin for AR or VR, you'll see your visualization in AR or in VR. So it's flexible and it's responsive to real-time modifications. So for example, I can keep changing my visualization. Here I'm extending it to a 3D scatter plot. This data is basically business index data, trading index data. So what I can do maybe is visualize it a bit differently. And if I want to view, for example, the trends per stocks, I can simply change the visualization to show the trend lines, for example. What I can keep doing, there you go, we'll see a bit better. just trying to get a resolution problem. I'm just trying to make it a bit more visible. So what else can we keep doing with these toolkits? Well, as I said, we can control the aesthetics, which is another notion involved in the grammar of graphics, which means I can bind color to the dimension of my data. For example, I can say, okay, I would like to bind a gradient color to the maximum, to the value when the stock opens, okay? And then what I can do is I can edit live, for example, my color coding, my color gradient. So I would say the low, I will use what we call ecological design. The low values are blue, and the high values, let's say, are red, okay? And so that what you see here is that the design is responsive. I can just change my visualization live into the Unity editor. Then I can also change the size dimension. For example, I can bind it to a given, whoops, got a beautiful bug here. It's a, I can just bind the size dimension to some other data set, to some other data dimension. So this is basically just demonstrating what I can build with visualization. I'll just maybe demonstrate what we can do. I'll just create another visualization again by drag and dropping. And this time I can create, for example, a parallel coordinates. So when I click the parallel coordinates paradigm, I get this this default parallel coordinates. And if I enter a VRAR, I'll just see it like as a massive parallel coordinate. Maybe what I'll show you is a couple of interesting things we can do with the toolkit too. As I was saying, we can create advanced visualization paradigms. Like, let me just build a couple of visualizations. So here I'll create this one. And here I create this one. Completely random. And okay, so I've got a scatter plot here with I'm visualizing the stock and the value when it opens. Here on this one, I'm visualizing the low value on the x-axis and the volume on the y-axis. And there you go, I've got two scatter plots. And what I can do, for example, is I can create a linked visualization, which is also another IATK frame. And I can basically bind, again, those visualizations and show the links. So here I can just basically show the links between the data points. I can control the transparency. And again, just to demonstrate the responsive design, the linked visualization also respond to the visualizations. So this was just a quick demo on authoring. So basically, this is just demonstrating that we can build visualizations simply with interacting with the Unity UI. So this was covering simple authoring. I'll just play the mini video just for very quickly what we can build with it. We can build all those type of visualizations. Cut matrices, very large data set like the FiberClay one. This is visualizing 1 million data points at 90 FPS when it's running. And we can, yeah, we can do all that. Okay, maybe I'll skip that for a bit later. There is also an API, a very simple API that builds on the factory design pattern, which is very common for daisy chaining actions, and it's kind of common when we build data visualizations. We usually chain commands. So we have an IATK view builder. Then what we can do is we can chain like commands such as setting the data dimensions. So I can just provided the data array in the format of IATK. I can just tell IATK to visualize dimensions on X, Y, and Z. And to do some further design, I can associate like a size and a color And if I press play, I'll obtain a visualization. So this is just to demonstrate that the authoring can also be done via an API to do for more advanced controls. Then I will talk about a bit about interaction. So IATK supports interactions that is specific to data visualization. As I was saying, visual analytics and data visualization is not only viewing a bunch of points, it's querying the data. So this is the work of my student, Benjamin Lee. He's built that tool called Fiesta using the IATK, and I'll get back on that again. And what we can do with IATK is we can programmatically obtain details on demand of the data points, and this is working at a very large scale of number of data points as well. So this is one type of interactions that is supported. We can do filtering. And again, I prefer to show the VR version because this is what you can achieve simply by putting the toolkit and just mapping the interactions to the controllers. And you can also do brushing and linking. Maybe I'll take a few minutes to go over that. So brushing and linking in data visualization is in multidimensional data visualization is a fundamental task. So data scientists can work, for example, with a 3D scatter plot or a 2D scatter plot, and they want to. So this gives them, like, if you want, like a window on the distribution of the data. And what they will do usually, they try to relate the data, how the data behaves in other dimensions. And so here we have a little demo of IATK basically doing linking a selection, a brushing selection in between a 3D scatter plot and the parallel coordinate and the scatter plot matrix. And so what's happening here is the user just put their hand in the data, and given a specific radius, the points within the hand radius are selected, and then they are highlighted in the corresponding visualizations in the scatter plot matrix. The other point about IATK is scalability. And just very briefly, we've tried IATK simply on the points rendering, but also on the line rendering was a similar approach. We achieved like a very, very high frame rate on standard pieces. And the paper from IEEE VR is from 2 years ago. So that was with a GTX 1080, not even Ti. I mean, we have to have a look at what I had 2 years ago. But we use like shaders and compute shaders to do selections and stuff like this. So basically, we achieved like a nice FPS scores for millions of data points. But of course, it drops when we reach the memory capacity of the graphics card, obviously, and the GPU and the CPU communication just can't cope with it as well. We also tried it on the HoloLens. So it behaves okay-ish until up until 10,000 points. It struggles with the next order of magnitude, simply because the GPU is not completely up to scale. But still, we still achieve, like, compared to the default ways, we still achieve nice FPS. So what I can do maybe is, as I'm seeing, I still have a bit of time. I can just show how to build the interaction, how to set up a very quick environment for an interactive, just a very simple interactive visual analytics tool in AR VR. So again, I create my data source, and here, for example, I will take a data set that is about the wine quality. Okay, so and this data set has something like 100,000 entries or something. And here I'm going to create a data visualization. And another one. Visualization. There you go. And I'm just going to illustrate a little interesting use case. So what I did is, if I just open my dataset to show you. let me open. So this is my data set. So this is the wine data set I was showing in iMaxis. And what I did is I just computed the dimensionality reductions. So I computed the t-SNE and the principal components. And I wanted to compare the two clustering outputs. And so what I get in the end, if I do that, is I can, for example, on that first visualization that I will call t-SNE, and the second I will call PCP. Oops. This, by the way, is a convention issue because we don't really talk about axes in dimensionality reduction. That doesn't really make sense, but because we use the paradigm of axes in IATK, this is our only option for now. We'll have to fix that. PC2. And again, I see some action on the chat. I'll try to have a look a bit later on. PC3. And here I just have like my two dimensionally reduced multidimensional data sets with 3D scatter plots. So this is basically a good example of using 3D in InfoVis because we can see a better separation in the clusters. So let's do a bit more design. I will bind the color dimension, for example, or the color palette to the type of wine. And we have white wine. So white wine, what color is it? Maybe we'll make it to be yellow like this. And we'll save it like this. And then red wine. I hope you can see my UI, otherwise it doesn't make sense. And then let's keep this. So we see that t-SNE did a pretty good job at separating the two types of wines on the non-trade labels and in the 3D visualizations. And here for the PCP, let's do the same arrangements. Let's bind the color palette to the type of wine, and white, let's bind into that recorded one, and this one to this one. And yeah, this is just a little use case of, for example, handling brushing and linking. So now let's say I wanted to, if I wanted to query the data, I can create a brushing and linking mechanism that will allow me to query the two visualizations, and I hope it's going to work as it's a live demo. But since the toolkit is from good engineering, it should work. 0, 0, okay. And so what I'll do is I'll basically tell that I've got two brushing visualizations. I've got the t-SNE. Again, this is demonstrating that we are doing simple authoring. So here I'm just building an interacting visualization system for AR in VR, just with drag and drop interactions. So I want to tell the system that yes, I'm brushing, that the color of the brushing should be maybe something a bit more salient, like blue. And the brush radius should be this. And that my brushing, this is my brushing object. So if I attach that little cube here to a controller, and then it will change the position in real time, then I can simply brush with my hands. So I will run, I will just run it in real time. And so if I basically bring my brush in the data set, I see that the points just highlight in the corresponding visualization. So this is interesting if I were a data scientist wanting to query two 3D visualizations that are linked, that are from the same data, but that's just showing two different type of output of dimensionality reduction. I could use this type of paradigms. Okay, so I'll go back to the presentation. So I just showed VR example, but this is another little work case. I've been working with UPS, the delivery company, and they were quite interested in that. So this is using the Meta 2 headset. So here I'm just using the hand position to brush. And so I'm brushing an augmented reality big scatter plots, a big map scatter plot that is right in front of my, virtually in front of me. and I can just brush that on my computer. It's just another use case of what you can do with the toolkit. And again, I will link of like what we can do using the API, just being wary of time as well. So we can basically build nice emerging interactions for abstract data viz with our toolkits. So that example I built with Andrew Cunningham from UNISA. We call that the accordion multidimensional data. So this type of interaction has been explored before for like slices of MRIs. So basically doing an accordion with human MRIs, but we're like, well, we should do it with abstract data because it's fun and it just shows like a different type of emerging interaction. I believe I still have 10 minutes. Yeah. What I could do as well is we can view. I could demonstrate what we can do with it as well. We can view, visualize, and build immersive visualizations for map data geographical data. So the toolkit integrates with Mapbox. So I'll save my example and I'll just create a. Let's kill it, and I will just demonstrate what we can build. So there is a lot of interest as well in using immersive spaces for geographic data, because we can basically view massive maps in AR and VR, and this has a lot of interest for the people in that field. And so what I'll do is I'll just upload this bike path dataset that has longitude and latitude data, and I will bind it to a visualization. I will basically bind the longitude, the longitude and latitude on the planar axis, like this. And I will use a different metaphor, bars. And let's say for the y-axis, we will use, for example, the step ID. So here I just, so these are basically just like bike paths with some additional multidimensional data. So what we did here is we just like, again, very quickly, if we, let me find the relevant view. That widget is so annoying. Okay, never mind. I'll just use it like this. If we look at it from the top like this, we have this sort of like geographical trail. So we understand if we were viewing it in an abstract way that it's geographic information. And let's reduce a little bit the size of the bars so we understand a bit better. But the thing, it would be quite useful if we had the map underneath to understand the data, right? So what we can do is we can add a map visualization component. So it's demonstrating that ATK is component based. And I can simply drag and drop, whoops, not the one, visualization here. And we are working to making that a bit better, simple. And if I run it, it will take just a few seconds because it's linked to Mapbox and it's fetching it's going to fetch the map underneath. And let me put a different color for the data visualization so we see what's happening. And so now I can just view my data in VR and AR. And again, if I can just completely control it, like I can rotate it, I can change the scale and so forth, and do some interesting stuff with it with VR controllers. So it was just showing a new additional thing that we've added to IATK that we can visualize these type of things. Maybe what I will do for the last 10 minutes, I think I've extensively shown what we can do with it. And I will show the link again. There are like multiple examples on our GitHub and how to build them. And this slide deck is also available on the GitHub. So there is all the pieces of code and all the instructions are available if you're interested. Maybe what I'll do is for the remaining part of the talk, I'll show what we've built with ATK, and it's not simply something that is just there in the drawers, but we actually use it to do research. and build some funny stuff with it, and some interesting data visualization things with it. So this is a paper from Kai this year that I published with my colleagues at Monash and UniSA, and Benjamin Barth from the University of Edinburgh. And so we built that tangible controller that we called the embodied axis. So it's a bit like the physicalization of the fader axis, of IM axis that I was showing just before. And we've been working with doctors and people who visualize MRIs and CT scans all the time. And we've just like rigged up a meta headset. And we basically built that like precise interaction device to query MRIs and CT scans. But what we did also is we visualize abstract data of patients. And so we used AATK basically to view the data and then interact with it with the controller. So this is a view from the meta. And again, with very simple, a few lines of code, you can hook up the toolkit and the visualization you build with it in Unity to controllers that you built. And if you want to control visualizations, what you can do it. This is another, I don't know if Tim talked about that because I was a bit late for his talk, but I'll just go over it very quickly. This is our most recent work in that space. This is the work of my PhD student, Benjamin Lee, and he's been building a collaborative VR platform to analyze for abstract data, multidimensional data visualization analysis. And he's basically interested in studying how people leverage space and volumes around them to arrange data. And so to support his research, he built a collaborative visualization environment based on IATK, and he deployed it on those. He deployed this on the backpacks, VR backpacks, and we run like a few groups of people doing collaborative multidimensional data analysis, as if they were like data analysts talking about data together in the VR environment. And so Fiesta is also available on GitHub, and it's kind of a nice thing because it's completely powered with AATK. And Benjamin also created like a lot of compelling additional interactions to create visualizations, stick them around in the space, and put them against wall and so forth. So this is the work of Tim, a student from Tim. And so Joe is basically interested in external cognition and arranging space around the user, arranging data around the user. And so his PhD is quite focused on small multiples, and which is basically like, as its name indicates, for the people who don't have like visualization background, these are just like different snippets of the data, according, for example, to time or to a given dimension. And so he's exploring the design space of this area. And so he used basically IATK to build like a bunch of visualizations because it scales nicely to his use case. And he's basically exploring different layouts of abstract visualization around the user in VR. And again, the great thing is Joe and Benjamin put all their work on GitHub, so feel free to reuse it. That's the work that I've done with Arnaud Clouseau, who was a postdoc in the group as well last year at Kai. So we also used the AATK to explore different multisensory exploration of data. So the paper was focused on mapping data density to the vibration on the controller, but we use AATK to support our research and display the data for the user because we had a use case where we were using fairly large data sets. So maybe before the takeaways, I usually use that slide in conferences, so people have their phones, but anyway, I'll paste the link. If you're interested in using it, it's available on GitHub. And briefly take a few takeaways. Something that is missing on this slide, and I would say first, it's not a commercial product, absolutely not. It's a prototype toolkit. There are people in the community patching it, working on it, which is amazing. So it's for research. It's there on GitHub. If you want to do this type of stuff, just go get it. It's cool. Again, it scales with nicely with the number of points to visualize. It's not a tool to transform and clean data. Your data should be a bit clean before. There are all the instructions. Yeah, it's a toolkit. It's designed to integrate with other packages. So you can do that. And it's open source project. Okay, thank you very much. Maybe I'm a bit under time, but.
Yeah, very good. Thank you very much, Maxime.
Thank you.